Welcome back. We're going to be talking today about risk and return. And in particular, we're going to try to estimate the discount rate for our individual company's stock. Yeah, I decided to choose a really odd background this time around. So, we're going to be using the capital asset pricing model. And to use the capital asset pricing model, we need a little bit of, so what is it we're going to be doing? So in class, we said that the stock was a function of systematic risk using the capital asset pricing model. And in particular, we're saying that the return to the stock, that's R sub S, is equal to the risk-free rate plus the risk premium times some measure of systematic risk that we're going to just call beta. Now that may look like BS, but it's actually beta sub S. The S for the beta is the same thing as it is for the return, and therefore it's beta sub S and return sub S. The risk premium that we're talking about is the market risk premium. It's the expected return to the market minus the risk-free rate, which makes some sense if you think of how much more above a risk-free rate would you have to pay just to get the market return. That's sort of like the baseline. Here's how much we're expecting to have to return just to get the market return. Then the beta, what it does is it essentially says, then how many times that are we going to make this stock return just because of the systematic risk. That's the philosophy behind the capital asset pricing model. Now, the way we're going to use this is we're going to use what's called a regression line. Regression is a linear statistical method, and it tries to find the best line that fits, well, this formula. Now, this formula looks nasty. It looks like it has nothing to do, in many ways, with the earlier formula. We have y sub I, that's whatever it is we're trying to estimate, is a function of an intercept term, which we're going to call alpha, plus beta times x sub I plus some random terms. Now the epsilon sub I at the end, by the way, we have to do alpha, beta, and epsilon, because if we put real, letters in there that you'd be more comfortable with, then it would look easy. But really all this is a straight line, and I'm going to show you that in just a sec. So the beta and the x, that's the slope and the variable. So whatever variable we're going to use for x, we're going to multiply it by some slope coefficient, which we'll call beta. We're going to add it to an intercept term called alpha, and we'll come up with the best estimate for whatever our output variable is, y. You may say, so what happened to epsilon? And first off, why did you go backwards? Because that's the way I think. Okay, so we deal with it. But the epsilon piece on the end is a random term, and we're assuming that it's random with an expected value of 0. So for the most part, we're going to ignore that when we're trying to figure out what we're expecting for y sub I. But the epsilon term is interesting because things won't always hit on that straight line. So we're creating a straight line. Once you give me an x, I'll just plug it into this straight line formula and come up with a y. The epsilon is saying it's not going to hit the line, it's going to hit somewhere off the line. That's all the epsilon is doing. So we're going to be using Excel to estimate these. And we're going to use two different approaches. The first is we're going to graph X and Y. Y so you can, and that's no pun intended, so that you can actually see what it's trying to do. So we're going to graph the X, we're going to graph the Y, and then we're going to plot them on the line. And then after we've plotted them, we're going to say, so now, what's the best line through all of this data? And it will fit the best line, and I'm hoping you remember from algebra where we did this y equals mx plus b, where m is the slope, b was the intercept, and then we just had the x and the y. So we're going to plot the x and the y, and then we're going to figure out what the best M and B are for that line. It's really the same thing as this. We're going to find the best beta and the best alpha for this line. Is the same thing as finding the best M and B in a y equals mx plus b line. The second way we're going to do this is actually running a regression analysis using what's called data analysis, which is really part of Excel, although you may have to add it into your version of Excel. I'll show you how to do that as well. Once we get the regression run, I'll show you how to actually first off, interpret the output. And second off, I will show you how to go from there to an estimate of, so therefore, how much of a return should there be. And then when we're finished with that, we'll go back and say, what beta did we get? What does beta mean, really briefly, which is just going to be review. I'm not doing that in this particular video lecture. We did it in class. It's in the book. And then we'll go out and see how close we came to what others have done, because beta is such a ubiquitous measure of systematic risk, and we can find several other groups estimating it on the internet, and so that's what we're going to do next. With that brief introduction, let me now move over to the internet, where we're going to try to find the data that were outlined in the formula. We needed return to the market, the risk-free rate, and we needed the return to the stockholder. So I'm going to do this in steps. I'm going to set this up just so that you can see how it's set up to begin with. And then I'm going to give you the template so you don't have to reinvent the wheel. Why in the world should you reinvent the wheel? So to begin with, I'm going to type in right up here in the URL finance.yahoo.com. Ooh, let me actually spell it right. At this point you can tell exactly what day I did this on. Wow. I did it on the last day of February. This is going to be loads of fun for you. So I'm going to grab the S&P 500, which, by the way, if it doesn't show up here, you can actually type in that same ticker symbol, which is the little thingy above the 6, and then GSPC. And we'll notice that it says S&P 500, and it finds something for the S&P 500. And this is really the S&P 500 index. It tells me what it closed at yesterday, and that at least the day before, from the day before, we're 0.49% higher. I'm going to grab the historical prices. And Yahoo does a nice job of this. By the way, we're going to go for monthly prices, so I'm going to hit monthly, tell it to get the prices. And there they are, February 3rd. And by the way, this will go back until January 3rd, 1950. We're not going to need quite that much, but what the heck. We're going to hit download to spreadsheet. I'm just going to have it open. And it's open in something called table. These are a little too narrow, so I'm going to widen it out a little bit. Now, note from the capital asset pricing model formula that it doesn't ask for stock price. It asks for return. And so what I'm going to do, because these are monthly data, I'm going to put return here. But note this is monthly. The M in this case does not stand for market, it stands for monthly. The R sub M in the capital asset pricing model stands for market. This is just monthly. This is just to remind me that these, I'm going to do the return formula from class. However, realize that what we're looking at are monthly returns, not annual returns. And what we really want out of this is an annual return. So I'm going to say equal. And the way this looks, by the way, we're just doing a percent change. So we're saying we started the month here, we ended here. So I'm going to do the ending amount minus the beginning amount, close parenthesis, divide by the beginning amount. So here's what we started with. Looking at this minus this as a return in dollars, then we have to divide it by how much we started with to find out what the percent change was. So from one month to the other, we had an increase of about 4.02%. Once I've finished that, I just have to go back up on top of it, go into the corners. We have our normal cell pointer kind of thing, and then we move into the corner of this, and it becomes really skinny and becomes what's called a fill handle. If we double click on that, it goes all the way to the bottom. Now I'm going to show you really quickly that the one at the bottom says, I don't know what you're talking about, because you're trying to divide by 0. Just so you know what it's trying to do, it's actually trying to divide by this empty cell. That's why that doesn't work. So I'm going to go on top of it and then hit my delete key, just because I'm being, well, a nerd, because quite frankly, we're not going down that far anyway. So I'm going to go next door to that and then say annual return. If this is the return per month, then I should get the annualized return by just taking the original number, monthly number, multiplying it by 12, should give me the annualized number, which is going to look really big and all over the place. So again, I'm just formatting, and there we have it. So this one is the return to the market. So I'm going to change the name so it doesn't say table on the tab. It says market. Whoops. There. Have heavy fingers, evidently. Now I'm going to go next back to Yahoo Finance. I'm going to type in the name of, or the ticker symbol of a company. In this case, I'm going to type in the ticker symbol of my company. And for this particular example, I'm going to use Rocky Brands, which is a boot manufacturer. And it's currently trading at $13.74 per share. I'm going to historical prices and monthly, get prices. And then as I zip down to the bottom, I'm going to do the same thing, download the spreadsheet. Open with is fine. And this one looks like this now. You say that looks, well, exactly the same. I should point out here, however, that as you look down this one, we have close, and we have adjusted close. The adjusted close is adjusting for dividends, stock splits, and all of that other junk. So that's always nice to know. You'll notice that as you move down a little ways, they're not the same. And they're not the same because for this company, they actually saw a dividend somewhere between here. Whoops, that's not true. Well, it may have just been between here and here. As you'll notice, that's when they start to diverge. We're going to be doing the same thing, but before I do the same thing, and because I like to cheat, I'm first off going to say this is actually RCKY. That's the ticker symbol. I'm going to right mouse button on top of that RCKY and drop down beyond where you can see to where it says move or copy. You pull this move or copy up so that you can see. I'm not going to create a copy this time. I'm going to move the whole thing from that particular file to the one that I started before, which was just called table. And I'm going to move it to the end. I'm going to say okie dokie. And now I have one fewer file for one thing. But now I'm going to grab my market and I'm going to highlight just those four. So I'm looking at H. I'm trying to pick up the heading, this formula, that heading, and that formula. I'm just going to copy, move over to Rocky Brands or RCKY, move to my H and hit enter, and it will pop those two in there. I'm going to highlight both of these numbers right here, just the top ones, because I'm grabbing the formulas. I'm going to double click on the edge and it's going to copy it all the way down. Just because I'm anal here, I'm going to get rid of my dividing by zero kind of thing, and we're finished with both of those. So far I have the following inputs. I have the return to the market, I have my return to the stock. So going back to the capital asset pricing model, I have my return to the stock, I have my return to the market. But what I need is the return to the stock and the market risk premium. I only have half of the market risk premium. I need the risk-free rate. So I'm popping back to the internet and I'm going to any search engine and type in Federal Reserve Economic data. Now the Federal Reserve Economic Data is called FRED, F-R-E-D, and it's part of the Federal Reserve Bank of St. Louis. So I'm going to just click on the one that looks like it says that. By the way, if you wanted to go straight there, I guess you could type in research.stlouisfed.org/FRED2/ and it would take you straight there. I never remember how to get there, so I just always type in Federal Reserve Economic Data. And since I go here on a regular basis, my search engines tend to remember that, and so when I start saying Federal Reserve, it's one of the things that pops up, so that's always a nice thing. I'm going into the different categories. What I'm really interested in are interest rates. And in particular, because I'm looking for risk-free rates, I should be looking for Treasury bills or Treasury bonds. Here's where we get a little bit of a divergence of opinions. The academics tend to look for Treasury bills because they don't have even any interest rate risk. Some practitioners, or quite a few practitioners, may say, you know, Federal Reserve themselves are messing with this one on a regular basis, number one. And number two, we're really looking at something that's a long-term investment. And so I'm going to look for a risk-free investment of the same maturity, which is going to be pretty long. So I'm going to go to Treasury constant maturity, and I'm going to look for a 20-year, because it's pretty long, constant maturity. I'm going to be looking for monthly, and I'm going to download the data and open that puppy up. And this is what it's going to look like. It says G20. Now to begin with, this looks like, okay, we're finished, but what are these numbers? These are percents. That's 3.08%, even though it's not actually in percent format. The other thing to note, by the way, is that these are backwards. Now before I actually show you how backwards they are, I'm going to go on top of this G20 tab, right click, again go down to move or copy, and whoops, let me move this up so where you can see it. So I'm going to move or copy and pop down to table. Notice I have not clicked create a copy because I don't need that to happen. I'm going to move to and hit OK. Now that I've gotten it over here, I want to point out market goes from most recent to oldest. So it's kind of, I don't know whether you call this ascending or descending, I guess, because these dates in Excel actually get bigger and bigger the later and later it gets. This is really a descending format. This one is a descending format, and this one is an ascending format. Well, that's kind of crappy. And so what I'm going to do is just turn it the other way around. So I'm going to go into data and go from Z to A, and we're finished. So all it did was just turn them upside down, which is what I needed it to do. So I'm going to double click on this one and call this the risk, ooh, I got heavy fingers, free. And I'm going to now move over to a new tab, pop, and we're going to say RS and risk premium. This is my X variable, this is my Y variable. And just so that I can get this to look as close as I can, I'm going to highlight the S up here. And then click on my little font thingy right there. And I'm going to subscript. Doesn't look like anything here, but you'll notice that it does subscript it here, which is kind of what I wanted. Now at this point we need to figure out whether we're all lined up time-wise. And generally speaking, these aren't necessarily lined up time-wise. And what I mean time-wise is if we look at our market, the date at the top is February. Look at my company, it's also February of this year. And then I look at the risk-free rate and it's 2014-01-01. Oh wait, that's not February. So what I'm going to do when I come over here and start filling these in, and oh by the way, I'm going to double click on my sheet and call it cap M. I'm now going to be looking at these in pairs so that I get my X variable, which is the risk premium, and my Y variable, which is the return to the stockholder. The stockholder return is fairly straightforward. It's just going to be whatever I have as the annual return for the stock. The X variable, though, is the return to the market minus the risk-free rate. They should be for the same time period. So because of that, I'm actually going to do this second one, this X variable, first. So I'm going to say equal market, and notice I'm not going to the one at the top because I have to have these line up. If yours do line up, great. If not, then I'm going to the second one. That's all I can say. Okay, so I'm going to the second one minus the risk-free rate for that same time period. So the 1st of January, 1st of January. Now, note that the value here is not 3.52%, it's 3.52, so I'm going to have to change it to percent by dividing by 100. And now I'm going to hit enter. For this one, that's kind of over the top, and I don't have to do this because I'm not going to really show it to anybody, but I like to do it just because it drives me nuts the way it is. So I have reduced the number of decimal points by hitting the decreased decimal right there, and then I'm going to go up in between B and C and double click, and it will size that column correctly. And then I'm going to go next door to the return to the stockholder and say equal that one. Now remember, again, I'm trying to make these line up, so I'm not going to grab the first one necessarily. I'm going to grab the one that says whatever the month is that my risk-free rate is I have available. And by the way, that's the only thing I have to put in that one, so we're finished. I'm going to highlight both of those and pull them down to about there, although I really only needed through 61, so I'm actually just going to go through 61 on my way back up. But before I even do that, I think this is a good place to stop this particular video lecture, just because at this point we have all of the data, we have the concepts, and then in the next video I'm actually going to say, so what kind of a relationship is there linearly, and we'll look at the two ways we said we were going to look at these. So this is a good place, a good stopping place. You can do whatever you want and then come back and look at the next video.